Welcome to Statistics for Surveys Session 3, Diagrams for a Single Variable, Segment 5, Histogram. For this segment, it will be really beneficial if you're familiar with the term frequency density and binning, which was discussed in Session 2, Segment 3. Mr. Pearson defined in 1895 a histogram as a term for common graphical representation, that is, by columns marking the areas the frequency corresponding to the range of their base. What makes this interesting is that he actually uses the areas to represent the frequency. Now, an area of, for example, this bar up here can be calculated by taking the width and then multiply it by the height of this bar. So in formula notation, the area equals the width times the height. Now, as Mr. Pearson defined it, the area is actually equal to the frequency, so we can substitute area by the word frequency. So the frequency is the width times the height. Now if you look carefully, the width in itself is actually the bin size. So we can substitute the word width with the bin size, and we're left with frequency equals the bin size times the height. Now if we want to divide both sides by bin size, we're then left with that the frequency divided by the bin size equals the height. Now we saw this before because this is exactly what frequency density is. Frequency density is therefore the height. In other words, the frequency density is the frequency divided by the bin size, and the height of the bars is therefore the frequency density. So if I wanted to know how many people are actually earning between 0 and 20,000, I'll calculate the area of this bin up here, which has a width of 2, so the bin size is 2. So let's write that down, 2. And the height is actually roughly 16, so times 16. So there were roughly 32 people who actually earned between 0 and $20,000 a year, per month. I don't really know. So what are the differences between a histogram and a bar chart? The bar chart was discussed in the previous segment, and it often looks a lot like a histogram. The bar chart is usually used for discrete data, while the histogram is used for continuous data that gets binned into different categories. The width of each bar in a bar chart can be freely chosen, but should be the same for each and every bar, while in a histogram it actually depends on the bin size. There are gaps between each bar in a bar chart to emphasize it's discrete, while in a histogram there are no gaps. Unless the frequency of a bin is 0, then you will hardly see anything there and it might appear as a gap. The height of each bar in a bar chart is any type of frequency except frequency density or relative frequency density, so anything that doesn't have density in it. So it can be cumulative frequencies, relative frequencies, etc. While in a histogram, we usually use frequency density. Unless all the bins have the exact same size, you can also use frequency. So many computer programs actually use frequency for the height, and it doesn't really matter much as long as all the bin sizes are the same.